Starting up the YouTube live, just a moment. Cool. Um, okay. All right, let's start with the first problem for today. So consider choosing a committee of 3 people from a club with 8 sophomores and 12 juniors. E1 is the event that committee has a sophomore, and E2 is the event that the committee has a junior. There are ABC questions. First question is that are the events in E1 and E2 independent? And B and C questions are just finding the conditional probabilities. So you guys have, I'm just gonna give you guys like 3 or 4 minutes to solve this, try it out, and we'll discuss after that. Okay, does anyone have any idea how to proceed for the, I guess the first one is pretty straightforward. Any ideas for the first, second, or third?
I would say that events 1 and 2 are not independent
Yeah.
because, yeah.
Okay. Um, yes. So the first, so in the three-person committee, if we were to choose, we have 8 sophomores and 12 juniors. It does affect whether the committee, whether choosing only sophomores. I mean, it does affect the probability of choosing 3 people. Um, if the committee only has sophomores or a committee has both sophomore and juniors, because if one of the places are filled with a junior, then um, all the 3 places wouldn't. It is impossible that all the 3 places will be filled with sophomores, so the probability will be changed. So sorry. So A not independent. And so what do you guys think about B? Okay. So probability that E1 occurs given that E2 doesn't occur. So this would technically mean that E2 is the event that committee has a junior. So E2 complement is the event that committee doesn't have a junior. So E2 complement is the event that no junior. So so E2 doesn't have a junior. So what would be the probability that the committee has a sophomore? So all 3 would technically be sophomore, right? So that would be choosing a sophomore is choosing all 3 places of the committee to be sophomore would be AC3 um, divided by uh, the sample space. Our sample space is no junior. So that would also be AC3 because we'd have to be choosing all 3 to be sophomores. That would be the probability will be 1. So similarly, it's the same case for the problem C. You have a probability of E2 given that E1 is E1 doesn't have occur. So that would be probability of E2 so in this case, we can also use a conditional probability formula, just basically probability of E2 occurring intersection E1 complement divided by probability of E1 complement. Oops. I'll just uh, so probability that the committee has a junior and the committee doesn't have a sophomore, which basically means all the 3 places of the committee are to be um, all all juniors. So that would mean that it would be C3 and our sample space, which is basically probably that it doesn't have a sophomore, just also probably uh, the 3-person committee is all juniors. That would be 12C3 again, which would be 1. Does this sound all right? Okay. So if you guys don't have any doubts, we'll just move on to the next question. Okay. Um, let's just do one thing. Let's move on to the to another problem where we have a 3-person committee problem again. Okay. Let's just solve this problem for now. Suppose, again, a three-person committee is formed for a club by drawing names out of the hat. If the club has 30 juniors and 20 seniors, what's the expected number of seniors on the committee? You guys can try it out. All right. Does anyone have any ideas how to solve this problem? Okay, I'll just continue with the solution then. So 3-person committee again. Let's put 3 blanks, 3 dashes. So we do have club with 30 juniors and 20 seniors. And we are to form a 3-person committee, and the questions ask you to find out the expected number of seniors on the committee. So firstly, we define our random variable to be, well, number of seniors. So let's x be the number of seniors, right? So what could be the numerical values for the outcomes, which basically means what could be the number of, what could be the values which the random variable x can take? Since we're forming a 3-person committee, that would be 1, 2, and 3. I'm sorry, I cannot see the chat. Right. Oh, 0, 1, 2, 3. Okay. Yeah. But I think in this case we're considering like the number of seniors to be there in the committee. So we'd only be considering like 1, 2, 3 right now. Because then 0, like it would technically not count. So right. So what's the probability that x equals to 1? There's 1 senior, right? So you guys need to select 1 senior from 20 seniors, and the other 2 would be juniors. So it would be for 20 choose 1 times the other 2 would be 30 choose 2 divided by 50 choose 3. And probably that x equals to 2, that would be choosing two places to be seniors. So that would be 20 choose 2, right? And the other place would be 30 choose 1. And also the sample space would be 50 choose 3. Also, probably that x equals to 3 would be you just choose all seniors. Okay. So right now we have had probabilities for each of the values that the random variable can take. So what's our expected value formula? So let's slide below. So that would be summation x p of x, right? Where x varies from 1, 2, and 3. So that would be 1 times p of 1 plus 2 times p of 2, or p of 2 is p of x equals to 2 in this case for each of the probabilities, and p of 3. So that's basically how the problem sums up. So that would be 1 times the p of 1 would be this value, this expression p of 1, and 2 times p of 2 would be this, and 3 times p of 3 would be this. I'm not going to go into the calculations, but the idea here is that you calculate the expected number of seniors using this formula. Also, I mean, now that some of you guys have mentioned x equals to 0, if you did consider x equals to 0 would technically not count in the average number of, in the average expected value, because you'd be basically be multiplying by 0. So you just have 1, 2, and 3. Okay.
Do you happen to have the, like, what it comes out mathematically? I know you don't want to, like, go through the work, because it's, but you have what the answer would be?
We just have to calculate it. I think, we should probably use a Wolfram Math website, but
That's okay.
wait, okay. But yeah, if you did use these expressions in order to evaluate your, in your steps, then you should be arriving at the right answer. Okay. Any other questions on this problem? All right, let's, there are no other questions, then let's move on to another problem in another slide. So is this the next problem? Okay, yeah. So another expected value problem. Assume a player on the baseball team has 1/3 probability of getting a hit and 1/6 probability of drawing a base on balls every time they appear at the plate. Suppose they negotiate their contract for an end of the season bonus of $1,000 for each hit and $100 for each base on balls. And if they expect 600 plate appearances, then how much should they expect their bonus to be? All right, same usual time, 3 or 4 minutes, and we'll try it out after later. Okay. Okay. So there's a question in chat. Is 1/3 the probability of getting a hit for every pitch, or just every time they're up to bat? I think it would be. So I just looked up plate appearance. So I think it's for every pitch. So okay. So how would you guys go about with this problem? Oh, so every bat. But I guess in this problem, since we're only considering the probabilities of an event happening or not happening, I really don't think it matters that much. Um, but basically, for every plate, either you get a hit or you draw a base on ball. So does anyone have any ideas? All right. So for every plate appearance, you either have two outcomes. You either walk the first base or not. So the success of walking to the first base can be either um, if the pitcher just throws I guess he throws 4 balls and then you can get to the first base and that's base on balls. So that's what I figured out. So that would be 1/6 of the time, or if the player hits it, that's 1/3 of the time, and that's success. So so you have 600 plate appearances, So let's calculate what's the um, expected number of hits in the plate appearances and the 600 plate appearances. So I think if you observe this problem, it would be a Bernoulli trial because each and every plate appearance is individual. You can imagine that a plate appearance is a trial. So each trial is independent of the previous one, and you have n trials, which is basically 600. And the success probability can either be 1/3 if it's a hit, and 1/6 if it's a base on balls. So you just calculate the expected number of hits. So that would be E of H equals N times P, right? That's the expected number of trials in which you succeed. So that would be 600 times 1/3. That would be 200. And okay, let's move it a little bit down. And also E of B, that would be also the same formula. That would be 600 times. Now this time the probability would be 1/6. So that would be 100. Now we just move on to the main question. What our question is to negotiate a contract for end of the season, a bonus of 100 for each hit. So you did calculate the expected number of hits throughout the plate appearances. So basically, in an year, they would be expected to have 200 hits and 100 base on balls. So what would be the bonus which they would be expecting? You just multiply it. For every hit, you have $1,000. So 1,000 times the total number of hits throughout the year, and $100 times the expected number of base and balls. That will be 100. That's the total bonus that they'll be receiving at the end of the year. Okay. So you guys can evaluate this. This is the math part. I think if you guys want the, that's how many zeros? 5 zeros. Plus. And okay. So that would be like 21, 210K. That would be the total bonus. Okay, so you guys have any questions on this? All right. Just jump in if you have any question. I'll just move on to the next problem. And I feel like this has already been covered, so I'll just move on to the. Okay, let's solve this one. Best of 5 series. I think this is similar to 2 of the homework problems, so we'll just solve a model of that. The problem states if the Bisons have a 3/5 probability of winning any given game against Mustangs, what will be the average length of best of 5 series between these two teams? So yeah, best of 5 basically means one team has won 3 games. I mean, if the team has won 3 games, that is won the series. All right, just 3 minutes again. Okay, you guys have any ideas to solve this problem? All right, so I'll just start with the solution. So Bisons and Mustangs. So Bisons have 3/5 probability of winning any given game against the Mustangs. So probability that Bison wins, we'll just define it with P of B equals 3/5. And probability that Mustang wins, just basically probability that Bison doesn't win, that would be 2/5. All right. Now again, we have the question stating average length of best of 5 series between these two teams. So what do we know about best of 5 series? B of best of 5 is that you can win with 3 and 0, you can win with 3 and 1, you can win with 3 and 2. The condition is that if a team has won 3 games, then it has won the series. So it can win 3 games at the start, the first 3 games, or it can lose lose 1 game in the first 3 games and win the last one, or it can lose 2 games in the first 3 games and win the last 2. So our model is going to be, I'll just simplify it again. It would be would be win. Any team, this is any team because we're considering total number of average length of the games and not average number of games that Bison wins, but we're in general considering total length of the games. I mean, in this case, average length of the game. So for 3 games, it will be all 3 victories by any team, 3-0. And when would we be getting 3-1? That would be a loss, a win, and the last one to be a win. And when would we be getting a 3-2? That would be 2 losses and then a victory. And then I guess it would be this, right? Yeah. So what do we have for the first condition or for the first line? It would be 3-0. That means that either all the 3 games are won by Bison. That would be 3/5 to the power 3. Or that would be all 3 games lost by Bison. That would be 3 games won by Mustang. That would be 2/5 cube. Right? So again, okay, let's go down a bit below. 3-1. What do you guys think about this? So the condition is that the last game should be one. If the last game were a loss, just like in this case, it would be extended to another game. So instead of 4 games played, it would be 5 games played. So that'll be 3-1. For 3-1, it would be 2 games won by Bison and 1 game lost, or 2 games lost by Bison, or actually, wait, I think it would be 3 games won by a team and 1 game lost, or 1 game, or vice versa. So that would be 2/5 whole cube, because we're considering the whole 4 games. So, but before this, the first loss can be in any of the 3 positions in the first 3 games. So that would be C3-1, right? 3,1. So that would be C3,1 times this probability. Oops. Okay. So moving on to the, I'll just move on to the next line in order to explain. So the next one will be 3,32. That would be LLWW, and the last game must be W in order for it to end on a 5-game series. So this, what would be the number of arrangements, or in this case, it would be 3C4,2, which means in the 4 places, you could place the losses or the wins at any of the 2 positions times. So the total probability, it's one game has either won 3 and lost 2, or it's the opposite. A team has lost 2 and the other team has won 3. Cool. So it's 3-1. In order to just simplify this, I'll just put the powers here. So in the 3-1 case, you have 3 games won by one team, 1 game lost by the same team, or 3 games won by the other team and one game lost by this team. All right, we have 3 different possibilities of 5-game series. So right now, what's the expected value? So let's define the first one to be P of 3 zip, and P of 3-1, and P of 3-2. Oops. Okay, so what's the expected length of the number of games? So that would be, again, expected length would be E of X, which is sigma X times the probability that X occurs. So in this case, 3 games are played. In this case, 4 games are played. In this case, 5 games are played. So our random variable would be X equals 3, 4, and 5, right? So this would be 3 times P of 3 plus 4 times P of 4. In this case, I've denoted it with 3 times 3,1 or 3-1. You can just denote it by 4 also, and this is 5 times P of 3-2, which is 5 games. So that would be the expected number of games played in the best of 5 series. Okay. I'm just so bad at drawing lines. Oh. So this is our answer. Do you guys have any other questions about this?
I've got a quick question.
Okay.
So when you have the 3-1 case, if you scroll up a little bit, why did you choose 3-1 and not 3-2? So like instead, so did you choose the losing team, I guess, in that case?
Yeah.
So if you choose the 2 winning spots, what does that look, how does that change the equation, I guess?
It wouldn't change because so mathematically choose 3,1 equals choose 3,2, and there's a reason for that, which would mean that even in order to place this loss in any of the 3, in any one of the 3 positions, that would be 3C1, right? And in order to place the wins, so how can you place wins in 3 places? That would be win, win, loss, win, loss, win, or loss, win, win. This is basically putting the loss in any of the 3 positions. So it's equivalent.
Okay, gotcha. Just making sure. I didn't know if that changed the math, I guess.
Nah, yeah, it wouldn't change the math. Okay.
Cool, thank you.
Okay. I guess we're out of time. If you guys have any other questions, just feel free to speak up, or yeah, I'll be here for around 2-3 minutes more.
I guess I'll ask another one. For homework, do you guys want us to find the actual number, like calculate everything, or can we just leave it as kind of how you've left it in here, where we just have, like if you scroll down just a little bit to the answer you found on that, like if we left it as that, or do you want us to find like an actual number?
I guess since it's the homework, I think it would probably be better if you calculate it to the final answer, like the integer which you get.
Okay,
Yeah.
gotcha.
Mhm.
Cool, thank you.
Okay.